Aaron, pick one, A or B.
A.
Before we do that, can you read the directions for us, Aaron?
Yeah, simplify each trig expression by using fundamental identities.
Aaron, name the 3 fundamental identities.
Reciprocal identity, quotient identity, and Pythagorean identity.
Oh, look at that. PQR. And you said A?
Yeah.
Alright, Aaron, which, if you had to describe to someone, simplify. Really, from yesterday's lesson, we're only using 2 trig functions. Do you know which 2 those are?
We're using sine and cosine.
Correct. So if you don't have that in your notes, when it says simplify, there's no equation, okay? You want to change them into sine and cosines. Write that down. Alright, Aaron. Do you want to do anything with cosecant?
Yes. I turned it into its reciprocal identity, 1 over sine of theta.
1 over sine of theta. Correct. Let's write that. Which identity did you use?
The reciprocal identity.
Reciprocal identity is correct. Aaron, did you do anything with the cosine?
I put cosine of theta over 1.
Thank you, Aaron. Aaron, what's your partner's name?
That's it. It's Jesus.
Jesus. What do we do next?
You can cross cancel. Cross cancel.
Okay, question. Cross multiply. That's like the butterfly, right? Or multiply across. Okay, when you multiply across, what do you get?
Cosine theta over sine theta.
Okay. Now what?
That equals cosine of theta.
How did you know it equals cotangent of theta?
Because that's the quotient identity.
Quotient identity. So these identities are like facts, and we just need to memorize those facts. I allow you to have a formula sheet, so you actually have all those identities. Alright, let's try the next one. Class, I want you to tell me yes or no. In this problem, do you think we're going to use the reciprocal identity? Yes or no? No. I don't see a fraction. Do you see that? I don't see 1 over something. Am I going to use the quotient identity? You could possibly turn that into sine squared t over cosine squared t, but I'm not going to. That means we're going to use the what? The Pythagorean identity. Taylor, your partner's name? Vincent. Which Pythagorean identity do you think we're going to use?
I don't know.
Do you have your formulation in front of you? So everyone, take out your formula sheet if you don't have one in front of you, unless you've memorized it. I highly encourage you to have flashcards. We're going to have something like 30 identities by the end of the month.
You have Pythagorean identity.
Okay, can you tell me the Pythagorean identity we're going to use?
Sine squared of theta plus cosine squared of theta equals 1.
Okay, but Vincent, I recognize I don't have sine and cosine. Is there another Pythagorean identity?
Tangent squared plus cotangent.
Tangent squared theta.
Plus 1 equals secant squared.
Okay. This is the one I want to use because I noticed they're both a tangent and secant in here. Do you see that? And they're also to the what? Squared, power of 2. How do I get this Pythagorean identity to look like this? Someone said add secant. But remember, I want secant to be negative. Minus secant. So we're going to subtract secant from both sides. This is going to give me tangent squared theta minus secant squared theta plus 1 equals 0. Are we there yet? What do I need to do? Subtract 1. What's left? Okay, what does this mean? This is a form of the Pythagorean identity. So not only did you have to figure out, okay, what's a relationship? I see this. I need to simplify. I could change them into sine and cosines, but one quick way is just knowing the Pythagorean identity. Vincent recognized it, and then we manipulated it, so it's equal to -1. So, I see tangent squared minus secant squared. Instead of writing all that, we're going to write -1 is our answer. That was it. But how do you get to that answer? You need to know your identities. So what did we do in this problem? We simplified our expressions using sine and cosines, and also our identities.